mode equals radians. And then let's set the window. What do you want the x to be between? Let's go from 0 to what? Let's go to 0 to 4 pi. And let's change the range to go from, how about negative 1.5 all the way to 1.5. Do that for me. Change it to look like that, and then see what it looks like. I want you to do this. y2 is equal to n deriv. Do you remember where to find that? Do you remember where to find that? Okay, so y2 n deriv. And then what do you think you need to plug in a few commands here, n deriv, and you might look a little different depending on the operating system of your calculator. It might look like this, and then you want to make it, there's two options here. It might look like the second one, and if it does that, d dx y1 evaluated at x equals x. How many people have something that looks like that? Make it look like the bottom one. Anybody have the n deriv, it looks like the top?
Well, I mean, you can do that.
I know, but does anybody have those words come up is what I'm saying? You do? Then you need to make it y1 comma x comma x. That's what you want it to say. And then press enter, everybody. The only thing I want you to change y1 to cosine, and then hit graph and see what happens. Where does cosine start? We know that. Cosine starts at what? 1. So it goes down, it goes up. Did you get a graph that looks like this? Kind of goes like that, right? Now, that right there is y is equal to cosine x, right? Where does the derivative start when the derivative starts? Where's the derivative starting? It starts at 0, right? Does it go up or down? It goes down, right? It's doing this, and then what's it doing? It's going up like this, right? Did it look like this? Looks like that, right? Now, is that sine? It's negative sine. Y prime is actually equal to negative sine of x. So here are the truths I'm giving you today. If f of x is equal to sine x, then f prime of x is equal to what? Cosine x. That's the kind of the direct one that you think it's going to be. If f of x is equal to cosine x, what's f prime going to be? Negative sine x. That's the key here. And with this information, you can do the derivatives of all the other trig functions because all the other trig functions are made out of what? Sine and cosine. They are made out of sine and cosine. So what's the next one you think you'd want to do next? What's the derivative? Which trig function would you want to know the derivative of next? We know sine, we know cosine, so tangent. So let's do that one. So let's say g of x was equal to tangent x, right? What is tangent? Sine of x over cosine of x. So if we wanted to do the derivative of this, d dx of sine of x over cosine of x, what rule would we have to use? Get up to the board with somebody else and do that for me right now. You did this out, you end up doing it, you end up with secant squared x. You have to remember that the derivative of tangent is secant squared. Now there's this chart we could fill out where we now know the derivative of cosine is negative sine of x, right? What's the derivative of 2 cosine? What's that 2 do? It's just what? Negative 2 sine x, right? And this is going to be negative 3 sine x, right? Anything change here? Not really. What about over here? Derivative of cosine is negative sine x, right? What's the derivative of cosine 2x? You have to use the chain rule. So it's going to be negative sine x, but what's going to go on the outside? A 2, because the derivative of 2x is what? So what about the next one? Negative 3 sine x. And this is negative 1/2 sine x. And this is negative 1/3 sine x. Are you okay with this now? Yeah. It's because it's a result of the chain rule. It's a result of the chain rule. So the generalized form of this is if f of x is a cosine x, what's the derivative of f of x? Negative a sine x, the derivative, right? What about this one right here? What's the derivative of g here? Negative k sine of kx. The derivative, remember? Oh, sorry. So we missed something in here. What goes on here? We forgot. We went too quickly here. What stays inside? The 2x and the 3x and the 1/2 x and the x over 3 because of the chain rule. The chain rule doesn't change the inside. It pops something out to the outside. Remember, like, what was the derivative? You can't see that. What was the derivative of e to the 2x?
E to the 2x
times 2. Yeah. The 2x stayed in the power, remember? Okay, so is the work really, really, really similar when you do it with sine instead of cosine? It's the exact same thing. So we have this now, though. We now have this. We also have if y is equal to tangent x, what does y prime equal? You have to remember this. Don't look at the board. What is it? Secant squared x. You say secant squared. Say secant squared. If you need to undo it, sometimes you will. Sometimes you need to simplify, but you start with, if I ask you, what's the derivative of tangent, you just say secant squared. Okay, so let's do some interesting ones. Let's do some fun ones instead.
But that's not 1 over cosine x.
It is. So secant squared x is the same thing as 1 over cosine squared x. That's the same thing. But when I ask you which one do I want you to state, just say secant squared. That is what I want you to say. You're not going to write it in terms of cosine. You're going to write it that way. So on this one right here, what rule are you going to have to use for f? What rule? What's the overall rule?
No.
Product rule, right? So what's that first function going to be? 3x squared. And what's the second function going to be? Well, no. What's the second? Sine of x, 1/2 x. Find me the derivative of f. Do that by hand. What is f prime of x going to be? Use the product rule and test. So let's pick another one here. What about this right here? Sine cubed. What does that mean when the 3 is right there? That just means sine cubed. That's it. Like over there, Natalie, sine squared, you're allowed to write it like that. That means, sorry, secant squared. So just in terms of notation, what does this mean? This means sine of t to the what? 3. So could someone tell me what's the first move I want to make if I wanted to find the derivative here? What's the first move? What do I bring? I bring something somewhere. What do I bring? Yeah, Noah. You bring 3 to the front. Do I change anything about the inside?
No.
No, so it's just sine of t to the what power now? But then I need to multiply by the derivative of sine. d dt of sine. The derivative in terms of t of sine. So I'm not done yet. I just wrote we now need. What rule did I use? So this is first the power rule. That was the first differentiation rule. Like what's the derivative of x squared? 2x. That's the power rule. But now we have to apply the chain rule. What is the derivative of sine? So if I were going to write this, I would write this as 3 times cosine t times sine squared t. This derivative right here is there, and then this just stayed like that. I just rewrote it a little bit.
So what are our two terms that were like, because we just kind of...
What are our what?
Wait, so that's using chain rule?
That's using chain rule, but we use the derivative of sine is cosine. I just wrote it in alphabetical order. That's what I tend to do. I write the trig functions in alphabetical order. Yes, David. Yep.
Oh wait, no. Never.
I just rewrote the question, Arvin. Let's say we had j of t is equal to cosine cubed of t. Well, that's the same thing as what? Cosine t to the what? Third. So what's j prime here? What's j prime of t going to be here? What do you bring to the front? 3. And then you have cosine t to the what power? 2. And then what's the derivative of cosine? Negative sine of t. Rearrange it a little bit. Negative 3 sine t cosine squared t. The only thing that pops out is the negative. Yes?
And why could we move the 3 in front of the cosine?
Because a times b times c is equal to c times b times a is equal to b times a times c. You can change the order of multiplication. What's that called? Multiplication is what? When you can change the order? Commutative. Good. Yeah, it's commutative. Multiplication is commutative. I just, generally speaking, I like to write the trig functions in alphabetical order. Okay, let's pick a different one. Let's see here. Ooh, this one.
These aren't that bad.
They are not that bad if you do them piece by piece. Do this one for me. You're like, dang it, I spoke too soon. No, I'll write this bigger for you. Try that one for me. You get your handle on the basic trig derivatives, you'll fly through these. So you have g prime, you're like, okay, it's just going to be ln 4 times 4 to this thing, but then you have to multiply by what? The derivative, d dx of 2 sine 3x. And what is that derivative? 6 cosine 3x. So you have this, this, and this. So the final answer is ln 4 times that times that. How do we?
This is the chain rule in the chain rule?
Yeah. So kids, first of all, you need to remember your basic, hyper basic trig, which is secant is what? 1 over cosine x. You also need to write full sentences. There's a lot of like scattered like pieces of math up on the board with no equal signs written in a circular fashion. So if you do the derivative of this, what rule are you now using? The quotient rule? So low, d high. What's the derivative of 1? Minus high d low. What's the derivative of cosine? negative sine of x, all over what? Cosine x squared. What goes away here? That's gone because cosine x times 0 is what?
0.
So we now have j of x is equal to, what's on top? Sine x over cosine squared x. This is an answer, but I want to show you the common way it's written. That is not how it's going to be written. That's equal to sine of x over what? Cosine x times what? Cosine x. What is, as David, you pointed out, what is sine over cosine?
Tangent.
So that's going to be tangent x times 1 over cosine. But what is 1 over cosine known as? Secant. So you have tangent x times secant x. Here's the truth you get to remember now. The derivative, if y is equal to secant x, y prime is equal to secant x times tangent x. That's another truth you get to memorize now. So the derivative of sine is? Derivative of cosine is? The derivative of tangent is? We just did it, remember?
Yeah, we did.
Secant squared. And the derivative of secant is? Secant tan. So there's one last one we have to do. What's the last one? Cosecant. So if y is equal to cosecant x, get back to the board, trade up with one person in your